Hello viewers, um, Mr. Nyati, your presenter, and Bharat Academy on YouTube. You can just search for that name, Bharat Academy. You can also do a search on Facebook. I go by the name of Bharat Academy. And then on TikTok, Nyati Bright. I'm back again with another video, which is now going to focus on section C of the 2025 past paper, which was written barely 2 months ago, if I'm not mistaken, which is basically a past paper which was written by GCE candidates. So we now go into section C and we move straight to the question. And the question reads as follows. So when you read this instruction, you discover that it tells you something special about this paper. To say, answer any two questions from this section in the spaces provided from pages 15 to 19. What does that mean? It simply means that this paper, starting from this GCE paper, going forward, there will be no answer booklets unless ECZ decides to change that. But as far as things are concerned, and as far as ECZ is concerned, the answer booklets are not a separate entity of this paper, but they are attached. Okay, there is space provided in the question paper itself, and that is why it is quite thick, where you have the spaces to answer your questions in section C. So even if a question requires you to do a graph, that question paper will come with a provision of a graph paper. So that's it about this paper. Even the grade 12s who are writing this year in 2025 will have the same arrangement, a similar paper which has answer booklets attached to the question paper, no separate answer booklets. All right, so we move to the question C1, which says, Elena prepared carbon dioxide gas in the laboratory by reacting 20 grams of marble chips with 1.0 molar, that is molarity basically, okay, hydrochloric acid solution. This is the concentration, okay. Oh, so you have a situation where you are reacting. Marble chips, by the way, is calcium carbonate, okay? And you have hydrochloric acid of a specific concentration. So when you have this kind of question, please bear in mind that you'll be required to write the chemical equation, and also, if possible, if this question is not about rates of chemical reactions, then you'll be required to do some calculation, find the number of moles or the limiting reagent and things like that. Or if it is about the rates of chemical reaction, you will be asked how you can increase the rate of chemical reaction, which factors you should consider, and also the things to do with catalysts, and also it can be a combination of both, where you will be asked questions relating to more concept and also chemical reactions or rate of chemical reactions. So that's what you should do always. It is easier to pass as long as you channel your mind into thinking about this question before, analytically, before you start answering this question. Understand the statement, then from there it will help you move forward. So construct the balanced chemical equation for the reaction. Include the state symbols. You have an allocation of 3 marks here. So what does that mean? So it's the preparation of carbon dioxide using calcium carbonate and hydrochloric acid as raw materials or as reactants. So in this case, you are going to write, this is C1, okay. So question A, we are going to say calcium carbonate which is a solid, plus hydrochloric acid, which is always in aqueous solution, to give you three products. One of the chemical characteristics or properties of acids is that acids react with reactive metals to produce salt and hydrogen gas. The other one is that acids react with bases to produce salt and water only. Acids react with carbonates to produce three products. One, carbon dioxide gas. Two, the salt. And three, water. So that you should know. So in this case, we're going to have three products, and this will be the salt, which is calcium chloride. Remember, calcium has a valence of 2, chlorine has a valence of 1, so we'll have a 2 here, and this is an aqueous solution, plus carbon dioxide gas plus water in liquid form. So this is the chemical reaction. This is the chemical reaction. But is the equation balanced? So the chemical equation may seem not to be balanced because we have 2 for chlorine and we have 1 chlorine this side. So we're going to put a coefficient of 2. And does it balance the equation? Calcium 1, carbon 1, carbon 1, oxygen 3, oxygen 2 plus 1, 3, hydrogen 2, hydrogen 2, chlorine 2, chlorine 2. This equation is balanced. We move on to the next question. The rate of reaction. Remember what I told you? The rate of reaction. Okay. For this reaction can be increased by altering some factors other than temperature and catalyst. State 2 other factors that would increase the rate of the chemical reaction. So there are quite a number of factors that affect the rate of the chemical reaction. What are some of the factors that affect the rate of the chemical reaction? Okay, number 1, we have temperature. Number 2, we have catalyst itself. I got this from the question because the question says apart from temperature and catalyst. So we begin by stating those. What are some of the factors? We have factors such as surface area, which is the same as particle size. Okay. Then we have the other one, which is concentration. We have the other one, which is pressure. This one is only applicable to gases. Okay. We have the other one, which is light. Okay. And so many more other factors which you can choose. Now, you have to be very careful in the way you select the factors that affect the rate of a chemical reaction for a particular question. Excuse me. In this case, you have this chemical reaction, and in the statement you've been told that 20 grams of this calcium carbonate marble chips was reacted with the concentration of this acid, which is hydrochloric acid. Okay? So now, when selecting the factors that affect the rate of the chemical reaction, you look at the question. These two reactants, each of them has a factor which, if you alter it, it changes the rate of a chemical reaction. In this case, when you look at calcium carbonate, in most cases, calcium carbonate comes as a rock, okay, as a lump. And so what can you do to calcium carbonate if it comes in that way for you to increase the rate of a chemical reaction? Which factor can you pick? Well, it is this one, surface area. You increase the surface area by crushing or grinding the marble chips so that it can increase the rate of a chemical reaction. Remember, the smaller the size, of reacting substances, the faster the rate of a chemical reaction. Why? Because you know that you are increasing the collision rate and the collision frequency, and also the the other reacting substance will be able to act on that particle whose size has been reduced in a faster rate. Okay, so this one is applicable to calcium carbonate. And then which one can you alter on hydrochloric acid for you to increase the rate of the chemical reaction other than temperature and catalyst? Well, it should be concentration. We have even been given concentration in this question. Okay, so those are the two factors. Now, if you had a reaction of gases, okay, such as, for example, you are reacting nitrogen gas plus hydrogen gas, okay, uh, you are reacting these to produce ammonia gas, and then a question is asked to say, other than catalyst and temperature, which other factor can you consider for you to increase the rate of the chemical production of ammonia? Now, of course, you know this, that this is the Haber process, but you need to think outside the box. So what else can you do? Remember, look at the factor which is only applicable to gases. So for this one, it is pressure. Okay, that is how you approach this question. It's not a matter of just picking anything. No, light to apply on this one. It may not even be applicable, but you are looking at what is applicable on each of the reactant. If you were to alter anything on the reactant for you to increase the rate of the chemical reaction, that is what you are going to consider. Okay, so what are the two factors? The two factors we're saying it's concentration and surface area. So now how do you answer? Because the question is saying the rate of this chemical reaction for this chemical reaction can be increased by altering some factors other than temperature. State two factors that would increase the rate of the chemical reaction. So the way you are going to state concentration and particle size will matter. So you are going to specifically state which one you are going to reduce, whose size you are going to reduce, and also the one whose concentration you are going to increase for you to increase the rate of a chemical reaction. So in this case, you're going to mention to say, grind marble chips in order to increase the surface area or to reduce the size of marble chips. The other one, you're going to say, increase the concentration of hydrochloric acid. So it's not a matter of just saying no concentration. The other one is surface. You need to specify. That's what an examiner is looking for. An examiner should not reach a point where during the marking process or marking time or duration, they should not reach a point where they are stuck on whether to award you with a mark or not because of the insufficiency of your answer. But they need to reach a point where when they look at an answer, they just continue doing what? Awarding you marks. Those are the things that you should look at whenever you are answering such questions. So we move forward. These are the factors. We are going to state them like this. So this is how you are going to answer. So you need to contextualize your answers. Your answers must be brought back into the level of being applicable to the question. Okay, so we move on to question C. By the way, on this question, remember we said there are 3 marks. So 1 mark is for correctly writing the equation, the formula. And when we say the formula, the correct symbols of the formula, 1 mark, you are going to get 1 mark. If you write the correct state symbols, you will be given another mark. And when you correctly balance your equation, you'll be given another mark, which sums up to 3 marks. And then question B, of course, you have 2 marks, 1 mark for the surface area, or if you are not good with the surface area in terms of remembering this, you can just say to reduce the particle size. Then this one also will be given a mark. And we move on to the next question. The next question says, question C says, the presence of a catalyst can also lead to an increase in the rate of the reaction. How does a catalyst increase the rate of a chemical reaction? Well, a catalyst increases the rate of a chemical reaction by lowering the activation energy, okay? The catalyst increases, that's what you need to know, okay? By lowering the activation energy. So this is the minimum amount of energy required to kickstart the chemical reaction. All right. So we move on to the next question. The next question says, that was C. We move on to question D. The carbon dioxide gas produced. Remember, this question is all about preparation of carbon dioxide in a lab, but we know that it's now, we've identified it to be under the topic of chemical reactions. The carbon dioxide gas produced was bubbled through lime water, which turned milky. Write the chemical formula, not chemical equation. Read the question carefully. We are told to say write the chemical formula of the compound that was produced at the produced that caused lime water to turn milky. All right. So now, first of all, we need to understand what really takes place whenever a reaction of such nature happens. Whenever you blow carbon dioxide, okay, into lime water, which is calcium hydroxide. So this equation is like this: calcium hydroxide, like so, okay, plus carbon dioxide gas. What does this give us? It gives us calcium carbonate plus water. This is what you get, and this is the cloud, which is the milky cloud which is formed. Okay, it's not a solution. Okay, but when you continue adding carbon dioxide to this, okay, you are adding carbon dioxide to these products. So when you continue adding carbon dioxide to calcium carbonate, you add carbon dioxide to a combination of calcium carbonate and water, okay? What you are going to produce are two products, which will now be colorless, or it will be a solution, and this is calcium hydrogen carbonate. Remember, hydrogen carbonate is a radical with a valence of 1 plus water itself. This is what you are going to produce when you continuously add carbon dioxide to this product. And if you have observed this, you can try this. You add, you blow, you get a straw and blow into a test tube of lime water, carbon dioxide. This is what you are going to see at first instance. After some time, you will observe that it becomes colorless, and that's why this one is in aqua solution, this one is a gas, that one is like that. Okay, that's what you need to understand. All right, so now, which one, according to the equation, to the question, write the chemical formula of the compound that was produced that caused the lime water turn milky. The one which is a solid is calcium carbonate. So we write this formula as, we are told to write the formula. So this is calcium carbonate. We move on to question D2. More carbon dioxide was bubbled into lime water that turned milky, and it became colorless, exactly what I was explaining. Write the balanced chemical equation for the reaction that took place. Okay. So the equation is this, and it's balanced because we have calcium 1, carbon 2, because of this. Then we have oxygen 3 plus 2, 5 plus 2, that is 7. Yeah, there's a 2 here, by the way. Then we have oxygen 2 times 3, that is 6 plus 1, 7. Then we have hydrogen 4. Then we have hydrogen 2 plus 2, that is 4. The equation is balanced. So the next question says, write the balanced chemical equation for the reaction that took place. So as well, we're just going to copy this equation and put it here as our answer. So we've just duplicated the equation, and this is the one. Move on to the next question. Explain why solid carbon dioxide, known as dry ice, undergoes sublimation. Well, anything that undergoes sublimation has very weak forces of attraction, and that's the reason why. It is because of the weak forces of attraction. That is the answer. Okay. And so that is the answer. Because carbon dioxide gas has weak forces of attraction, or weak let me not say forces of attraction, but let me say weak intermolecular, since it's a molecule, intermolecular forces of attraction or intermolecular bonds. It has weak intermolecular bonds or intermolecular forces of attraction. And then you can also say that it does not stabilize in liquid state. It doesn't stabilize. It's not stable in a liquid state, and that's why it just changes directly from solid to gas. That is the reason. And ladies and gentlemen, and candidates, viewers, I hope this video has been helpful, and bye bye for now.